Hello friends, the lesson of today is the parallel line. By the end of this lesson, the learner will be able to verify two lines are parallel. Rule you have to know here: lines are parallel if they have the same gradients. Yes, means that if two lines have the same gradients, means that you conclude that two lines are parallel. Consider two lines. The first line is y is equal to m1x plus c1, where m1 is a gradient of the first lines, and the y2 is equal to m2x plus c2, means that m2 is the gradient of the second line, where c1 is a constant value of line 1 and c2 is a constant value of line 2. Now, if gradients or slope of line 1 is equal to slope or gradient of line 2, means that you conclude that line 1 and line 2 are parallel. Yes. If the slope of line 1 is equal to the slope of the second line, you conclude that those lines are parallel. So now let us take an example here. So compare the following equation of line. Here we have y is equal to x plus 4. So another example, y is 2y is equal to 4x minus 6. So now this is A, example A. About the example B, so y is equal to x plus 4. So y is equal to 2x minus 5. So now compare the following example. Yes, verify two lines are parallel. Yes, about the question A. Yes, so y is equal to 2x plus 4. This is equation 1, or is line 1, where the gradients m1 is equal to the gradients of the first equation is equal to. About the second lines, we have 2y is equal to 4x minus 6. So now y is equal to 4x minus 6 over 2. So y is equal to 2x minus 6. And now the gradients of the second line is equal to. So about the second example, so now the gradients of equation 1 is equal to 1, because here we have the coefficients of 1. So now about the gradients of the second equation of line is equal to. So now for the first example, yes, for the first example, or for example A, m1 is equal to m2. So now while for the second example, m1 is different to m2, and now you conclude that A equation of line, yes, lines A are parallel because m1 is equal to m2, while equation on about the second example, equation 1 is not parallel to equation 2 because m1 is different to m2. Here we have example. Find the equation of line which pass through the points 2, 1 and is parallel to 2y is equal to 2 minus 6x. Means that we ask to find the other equation of line which pass through point 2 1, and now it is parallel to equation 2y, which is equal to minus 6x. So now let us find the equation of line. So now here we have the equation of line. We have a 2y, which is equal to minus 6x. Remember, equation of line, it is written as y, which is equal to mx plus c. So now change the equation of line, we get y is equal to minus 6x plus 2 divided by 2. So now y is equal to minus 3x plus 1. This is the equation of line. So now the gradients m1 is equal to negative 3, because the negative 3 is a coefficient of x. So now remember that two lines are parallel if and only if m1 is equal to m2. So remember that m1 is equal to negative 3, means that negative 3 is equal to m2, means that the second gradient, the m2, is equal to negative 3. So now if the gradient of the second equation is equal to negative 3, means that we are going to find the equation of line passing through point of 2 and 1, yes, means that with the gradient of negative 3 we are going to find the other equation of line, yes, the other equation of line passing through points 2 and 1, yes, which is parallel to with the gradient of negative 3, means that remember that the equation of lines y minus y0 is equal to m bracket x minus x0. So now y means that where x0 is equal to and y0 is equal to 1. So now replace each term by its value. Y minus y0 is equal to 1 is equal to m is equal to negative 3 bracket x minus x0 is equal to. Okay, so now y minus 1, removing bracket, is equal to minus 3 times x minus 3 x minus 3 times minus, we get plus 6. Okay, so now y correcting like term is equal to minus 3x plus 6 plus 1. So now y it become y is equal to negative 3x 6 plus 1 plus 7. So now this is the second equation of line, yes, means that you conclude that equation of line y1, the first equation, is equal to negative 3x plus 1, yes, is parallel to the second equation y, which is equal to negative 3x plus 7. So and now here means that m1 is equal to negative 3, while m2 is equal to negative 3, means that m1 is equal to m2, means that you conclude that two equations of line are parallel. So now thank you students for watching this video. If you like it, don't forget to click on subscribe, like, share and comments. Bye bye.